Hi, we'll just wait for a few minutes and then start. In the meantime, if you guys have any questions, I can take those. Okay, I guess we can start. Just recap last week's topics and then move on to today's topics. Okay, so um, right. So we saw how to use auto, right? This is a feature in it's a feature in modern C++ where you do not need to define the data type of a variable. It infers the data type from the value it is assigned. Okay. So because I'm assigning 7 to X, the data type for X is determined by auto at compilation time. So it still respects the fact that in C++, data types are compiled and constant. Okay. Now that thing doesn't change. Important thing is you do not have to explicitly define in certain situations the data type explicitly. That's the main thing, main motive behind using auto. Okay. And sometimes because of namespaces and other things, right? So for example, if you have a map, okay, so we define a map, standard map, integer, integer. So it takes a lot of templates. So your data type itself, here we want to access the beginning of the map. So you use the dot begin, which returns a iterator. Now this iterator has the data type of this. And depending on the inputs and all to the as in inputs to the templates, this can become quite large. And from perspective of readability, it doesn't really make sense to write the complete data type here. While yes, it makes sense to always have the data type for the um, whoever reads the code to actually understand this code line, right? Yes, it does make sense, but honestly, here it doesn't really matter because we know we'll be using an iterator for the begin map. So for example, like this, where we want to start the iterator, so we do not need to put, we don't need to actually specify. It knows we know what it is. We can just put auto, then increment the iterator, and then start printing stuff or whatever you want to do. So in cases like this, you can avoid using the explicit data types. And in a way speaking, you can actually make your code more readable. So few of these things are the reason why people use auto. Other thing is maybe there is a function which returns some data member. Okay. Um, we sort of, let's say you know what you want to do with it and don't really care what the data type is returning, or maybe sometimes it could be a function which can return multiple data types, let's say. So during compilation time, if you have we did talk about const expression, I think. In any case, during compilation, you might have different definition of the function, okay, compiled, let's say. So auto will take care of which data type it will take of corresponding to which function. You don't have to explicitly specify it and write the same return type for every compilation line. Something like that also can be automated. So there are multiple reasons you might want to use auto. So this is another one. And yeah, if we see this example, like we just discussed, the iterator makes this code more, like using auto makes this code more readable. Otherwise, we'll have too many parameters here in itself in the for loop. Okay. Other thing is about auto y equal to x. Because the data type for x is known, y can also infer what the data type is. And then we can also define const auto y and const auto pointer and taking the address of x. Okay, you can also make const auto reference of y, which basically takes map, okay, and then makes a reference to it. Important thing to note, auto only takes the base data type, as in it you have to yourself specify const, okay, or const pointer or const reference yourself. Okay, it doesn't automatically take that. All right. think I'm not okay. Yeah. So anyway, right. So const is one thing you have to yourself specify. Okay. And if you take this example, so yeah, exactly. So for this example, we took y to be auto reference of map. So its data type is also standard map integer. Okay. With const qualified because we specifically mention it, which means we cannot change the data type explicit, like directly, okay, through y. The other way is if you have map and you use an iterator, which is not begin but c begin. Again, this is also an iterator, but the speciality is that it is a const iterator. Okay, so it behaves like an iterator, exactly like what this thing does, but it has a constness attached to it. So when you do perform auto begin const, like let's say I define some variable, this iterator automatically has const. Okay, don't get confused. Here the auto has const, not because we have to like it's the base data, because the base data type itself has the constness to it. Okay, you do not need to add another const here, but this iterator will behave as a const, which will be same as if we have y dot uh, begin. Okay, so here y dot begin and map begin const will behave the same way. Okay, maybe I'll just mention that. Okay, I hope it's clear so far. And yeah, other thing we saw is decal type. Okay, so this is two. So maybe we see the one first. The other thing is yeah, type ID. So type ID, the reason to use is to get the data type. Okay, so we have A, B, C, and let's say we want to see the types of whatever type it returns. So can we use type ID, pass that variable, and then call the function, member function with dot name. Okay, this will tell you what the data type for that variable is. The other thing to look for is it's sort of similar to auto, but a slight difference. Yeah, similar to auto, but a slight difference. Something called a decal type, where there is a if for example, if there is an integer a with and pointer p, so we're defining it. The next thing we can do is let's say we define auto a. So this is what I've seen before. Just defining auto b will throw an error because it can't infer the data type of b. Okay. Let's say we want to define b with the data type of a itself. So this line will always work. If I have already defined a somewhere, here supposedly I defined as integer. So this line is fine. For example, let's say if I had if defs, so some macros or something which during compilation time checks for some kind of flags, okay, and then defines a to be integer, float, or double, or so on. The nice thing is because of this line, I do not need to worry and change it because I am and it ensures that the data type of B will always be the data type of A. So decal type of A, okay, maybe I should reiterate this also. The decal type of A returns the data type of A itself, which you can. So this line is essentially a replacement for using whatever the data type of A is, so which is integer. So you can think like, so this whole thing is sort of replaced with integer and then B is defined. Similarly, the nice thing is P is a pointer, integer pointer. So Q is defined to be an integer pointer. Okay. Now that's the thing about decal types. Okay. Useful because you do not have to worry about explicitly what the data type of whatever variable you want to choose and then define the other one. It automatically sometimes it is important because you might have code which changes data types, let's say for such certain variables like a with some condition during compilation time. Okay, and With code like this, you don't have to change the rest of the code. It automatically takes care of it. Okay. So there is a lot of reuse that happens, and it doesn't make the code more bloated. All right. It's all about learning about these functionalities and using them at the correct and the right place and the right time. Okay. Right. Then we say, take this example where we see the decal type and auto difference. We define an integer a, which let's say I store 10 into it. I define an integer, I define b with a reference, okay, integer reference, taking a to be the input. So b and a are essentially the same uh, variables. Then I define a const integer c with 11. Okay, so that here the data type of c is constant. The data type of b is integer ampersand. Okay, as in, so that's the integer reference, and a is integer. Similarly, d is constant integer reference. So that's what its data type is, and it points to c. Now I define variables auto underscore a, b, auto underscore c, underscore b, auto underscore c, auto underscore d, all this with and define them to be of data type auto, inferred from each of the variables ABC. So here we see what will be the data type of each of them. Okay, so all of them will be integer, because remember, whatever auto infers from the data type, which is whatever we put it on the right hand side. Okay, those data type is all auto always infers the base data type. So here it is always integer. So having reference or constants or pointers or anything is additional qualifiers for auto. Okay. And let's say I put auto reference and then variable with a, it will infer a to be integer. Okay. But it also, because we have put ampersand, now the variable var, its data type is integer reference. Okay. Similarly, if you add a const, it becomes a const reference, integer reference. Okay, I hope this is also clear. Other thing you can do is use decal type and then define variables with a, b, c, d underscore decal, and have the right hand side very similar to auto as a, b, c, d. Okay, have the decal type on the left. Okay, as defining the data type for each of these variables. And then if you see the data type for each of them, here it will be different from auto, because decal type itself takes the actual data type it is inferring, like whatever it's inferring from inputs. So since a is defined to be integer, here a decal will also be integer. B is integer reference, so again b decal will be integer reference. C decal is constant, so constant, and naturally d decal is constant integer reference because d itself is constant integer reference. Okay. Then, yeah, this is also something we saw, where you define an unsigned int as 10, and let's say the decal type is e, of e is taken, so which is unsigned int. And you try to assign a negative number to it. Ideally, it can't represent that, but there is a defined behavior where it wraps around from the largest value it can represent. So unsigned int goes like 4.2 billion something, and we saw the output there if you try to print f. So a large number basically gets printed. Okay. Let's get it type ID too. So initialize a list where it's essentially kind of a container. Okay, so initialize a list, you have to put the header file to use it. It's kind of a container where you can store some data, and this is a templatized class. Okay, and all of the data needs to be the same. Is there any question? Oh, okay. Yeah. So if you have any questions, you guys can feel free to interrupt me or put your questions in the chat also. All right. So initializer list here is taken to be of integers. Okay. And they all need to think of it like a list of elements, but they need to be of same data type. Okay. Now this initializer list can be defined with auto. Okay. It is a valid code and the compiler won't complain because it can infer the data type of this list from the elements. And the way to define this is using curly braces. Okay, so this is the syntax that defines an initializer list. Okay, and because it initializes this values, okay, it knows what the auto will stand for. Standard initializer list with integers. Okay. The other thing to note here is we can define a to be 1 with an auto and it will be integer. That's fine. There's another way you can think of defining variables, something like this, where you're passing 1, so let's say, to B as an input parameter. We haven't defined B to be a class or something, but you can think, because of C++, you can think even integers to be a class of itself. In itself is a class where it takes 1 as the input parameter, as this is the construction of an object, the defining object passing the variables. Okay, here the constructor gets called, all the other things, whatever needs to happen, and data allocation and everything for that class gets done. Okay, just so happens that it's not a very full-fledged class in itself because integer just stores memory. That's it. But nonetheless, you can think it of this way, of this in that way. So it stores 1 inside B. Okay, and the auto automatically defines its data type to be integer. Okay. Then other thing is having this C1. Okay. Here it infers its data type to be standard initializer list of integer. Okay. We saw that some of them will throw error and not. So that's there. Yeah. Here it could not infer the data type if we just put it this way. But if you have as an equal to, it is fine. But this line having it as like a initializer list as if you're passing all the variable more than one variable, then it gets confused. So this one will throw an error. But this is okay. We'll create an initializer list sort of in the same motivation from as we do for objects, class and objects, similar to that, but for only one variable. This example I just put because you guys should not confuse between this bracket and this bracket. That's actually the main motive. And you also learn about initializer list. So if you guys have need for these kind of data structures, you can absolutely do it. Okay. All right. Any questions so far? Okay. Awesome. All right. In that case, maybe we'll move on to the next topics. So today we'll learn about lambda functions. Okay. Lambda expressions essentially. Yeah. So the idea behind lambda expressions is that you can do function programming with it. Now we'll just see these examples and then sort of understand what this function programming itself is. Okay. All right. Let's go. So before doing anything, I have to include the header files because we'll be printing stuff. So I stream it is. Let's define a global variable. Okay. So let's say this is 10. Then write a function, remainder function. Okay. Remainder. Yeah. Which takes a variable n. Okay. Capital N. And returns the remainder n percentage. Is it? Yeah. With m. The reason I want this is because I don't want to worry about M being so as a, okay, think of this. I want M to be constant and to be a variable wherever I just want that I just want to know the remainder whenever I pass any integer n, capital N. Okay. So whatever this will be result, I just want that result. Okay. Here I'm sort of you can think like I'm keeping the M constant. Here small m is a global variable. It's a const. Yes. It's an integer, yes, but it's a global variable and in the scope so that you can even call it in the scope of remainder. Okay, I don't want to actually pass it, so that's the thing. Anyway, so let's write the main function and then start getting some output. So it returns 0. Okay. Now this is straightforward. I just print remainder. Okay. And then the remainder function takes, let's say, my past 15 to it. Okay. Then end the line. So just format this. Okay. Lambda. Okay. I guess the code is straightforward. We're just in defining small m to be 10 and define a function remainder. Sorry, define a function remainder which takes capital N and then returns the remainder when it's divided by n, small m. And we just call that function with some uh, output as remainder. Okay. Give the input as 15 and just print it. Straightforward. Oh, my bad. I used the wrong bracket. Yeah. All right. So this prints remainder 5. Okay. So far so good. All right. As this is the result we expect, if we divide 15 by 10, the remainder is 5. Okay. The same thing. Okay. You can also do it this way. So look at different different ways of doing the same thing, and then try to relate how or why we are doing all this. Okay. Let me call this as 1. So again, I'll include string. I'll define a struct. Okay. This time the function is not remainder is not just a function, it's a struct. Okay. Struct is also very similar to a class. Okay. But not as feature rich. Okay. Struct also is present in C where it sort of behaves like a class. Okay. But it's not as feature rich as a proper class, which is there in C++. Okay. So let's define the same M. Okay. I define a function similar to before. Okay. The M here was a global variable. I sort of don't want to pass it to M remainder function many times. So hence I just did this. Yeah, I'll come to that. You just have to hold on. I'll show you different ways of doing the same thing, and then we'll start relating to them. Okay. So right. What I will do then do is define this remainder. Okay, sort of like a constructor for it. Oh, okay. Struct in class. Think of it this way. Class have proper definitions like constructor, destructor, private members, public members, protected members. Then you can have derived classes, all that nice things. You can have virtual functions. You can have friend functions. all these functionalities are present in classes. Let's just say most of it is not there in struct. Okay. All right. So struct also sort of has a constructor. So I'll do that. It takes an n, okay, and then its internal member m stored for like stored has to be n. Okay. Next, so this is the constructor. I just keep it this way. Okay. Then I define operator. This time I'm going to define this operator. So the bracket operator, uh, recall, it's similar to using a function is an object of remainder, okay, of struct remainder, but with these brackets, okay, will mean that it takes an integer capital N, but then you can use this parenthesis operator to do this. Return n percentage n. Okay. Again, I'll write main function. Define now we'll create an object for this struct. Okay. We'll create a struct remainder. Basically this name. Okay. We'll call it rem. The object's name is rem. Okay. Then pass a variable 10. Okay. So what this will do is it constructs it takes input 10, which is the and here the constructor gets called. Okay. So the construction is this line. It takes the value small n. Okay, maybe I'll just not get confused. Do it this way. Okay. So underscore m is sort of like a throwaway variable. Okay. So 10 is underscore m here. It sets small m to underscore m. That's what the constructor does. So our internal member variable, which we cannot change, okay, for the specific instance of the object gets created and is initialized. So that's what 10 is. Sort of very similar to this case, where we defined m to be 10 and put it as a const, which cannot be changed for the rest of the code. Okay. Here there's a little more freedom. In that sense, I can have different objects of remainder. Each will have its own small m defined. Okay. I'll format this to look for me to know here. Okay. All right. I hope this contrast between these two is clear. And now we will do the same thing as we did before, which is do you want me to explain it again? Line 14. Rem is the object. Think of it like this whole thing from here to here is the so if you had a custom class, you wouldn't have okay, think of this is not there. And remainder is the name of the class. Okay. Just so happens that the syntax for struct is that you have to have the struct keyword also with the name of the struct and then the name of the object of that struct. Okay. And this is the input for the constructor. So essentially this line calls the constructor of remainder struct, not class, remainder struct, which is this line. Okay. Okay. That's clear, I hope. Same line as before. We'll have a remainder. We print the remainder now. But this time, if you see, uh, my bad. Yeah. Previously, I had a function here and I could just pass the number. So remainder is the function. Okay. Pass the number, let's say 15, and then get the output. So that's what it did here. Slightly different, but this time I'll have an object and then pass 15 here. Don't get confused to this line and this line. They look the same, but here the constructor gets called. Okay. Here the a function gets called. What is the function? It is this operator with those two brackets. Okay. I have sort of defined it to be this way, so I can use this function. All right. then do standard endline. Sorry. Then we'll have the return 0 line plus why not. Okay. Now let's print the same thing and see the output. Remainder is 5. So it works pretty much the same as before, but in a different way. Okay. So one way here is define a global variable and then define a remainder function for it to take different inputs and always divide it by some divisor which is constant. Okay. Very similar to that. Here we define a struct to do the same, and each time a struct gets defined, it has different divisors. A little better, but and achieves the same thing. Okay. Now we'll look at another example. It's not a predefined function. I mean, we are defining it. Think of it like there's actually no difference between this integer. Sorry, this is a function, right? It has a data type. It returns. It has a data type which it takes at parameter. So some parameters with some data type it takes in and a body. Essentially, this is what also the same thing with operator. The reason it looks a little different is it is not a normal function. It acts in a different way. It's executed through the variable, the objects. When the object is called with these brackets, it looks a little different, but it's also a function. You can have multiple operators. You can have this with these variables. You can have with the square brackets. You can have different definitions, and then call them accordingly. Yeah, that's absolutely okay. Okay. Oh, it knows, right? So if you have square brackets like this, sorry, if you have square brackets and small brackets, so if you use square brackets, it will use the square bracket definition and vice versa. Yeah, line 15, yes. See, here the constructor gets called because here the first time the object is defined. Anytime you call anything else from that object, okay, then the operator gets called. Yes, then it depends on the brackets. Here, if you see the remainder, constructor expects inputs in a bracket. You can think that way also. That's how constructors are defined. Okay. Perfect. Then I'll include iostream if we want to print things. This time, we did through function. We did it through struct. Now we will do it through something called a functor. A functor is essentially a class which behaves like a function. So what is it? We'll define a public numbers. So first the operator takes integer n, returns, let's say n plus 5. Another function defined in this class is an increment. Takes n, returns n plus 1. Okay. Integer main function. Functor. Okay, so this is also a sort of a concept in C++. called functors, where these are actually functions. These are actually classes, but behave like functions. Okay, so I'll define a functor. Func is the object, so func is the functor with the data type functor because that is the class. Okay, this is the declaration. So the constructor gets called. We use the default constructor. Okay, and then all functions through. So functor print will look like something like this. All right. So essentially what I did is I declared the functor func. Okay. Now I'm using as it with some bracket and passing some value I. This will call this function. Okay. Next, I can call the increment operator true. Okay. But this time I can't just directly use this way. I have to do it this way because I have to access a member of that function. Okay. Yeah, output will be 10. And the second one? Correct. Let's compile and print as expected, right? That's correct. So functor prints 10 and 6. This is another way to look at functions, okay, where you can actually pass a object, but the motive behind using this object or defining this class itself is that it has various functions inside it. So a collection of functions can be used from a single object. Okay, multiple operator. I hope this will work. Let's define it this way. This time this will be, let's say, not 5, but 4. And I hope this works. Print, let's call it print. Or maybe put it this way. All right. Okay. Now this is clear. So in the first one, it uses this definition. In the second one, which I wrote, okay, it uses the brackets because I have defined the bracket operator to be n plus 4. So it prints 9. The second one, we use the increment function. So it prints n plus 1, which is 6. Okay, okay. All right. Now look at another example. Yeah, exactly. I'm just coming to the lambda function. Now we'll learn about lambda function. So far, we looked at different ways of doing stuff. Okay, there is a commonality here. There's a reason why I did the same function in 3 different ways. Now we'll see how to do the same exact thing in through lambda expressions. Okay. The first one, I'll maybe recap. Sure, why not? The first one is using functions with a constant defined divisor. Okay. Second one is using structs. Okay, where I define functions so I can do remainders and all. Okay. Here I define the divisor through the construction of the struct itself. So construction of while the object is getting constructed. All right. Then the third one is using classes. So this was with structs, very similar to that. You can also use classes. I don't do the remainder, but I guess you get this idea. You can write a constructor pretty much the same way here. Okay. Code pretty much remains the same. Just replace struct with class, and struct here you don't need to define, and the whole code will work if you make it a class. Okay. But the idea is that classes like this are actually called functors, where it's a class but behaves like a function. Also, if you think about this line here, okay, previously I used the object as a function. Here I actually used a function, I put an input, remainder 15, and got the output. Here I have an object, I call it a rem, but let's say I call something, give the brackets, put 15, I get the output. Essentially, these two are achieving the same thing for the same syntax. Okay, takes 15, have a name, give brackets, put 15, returns 10. Sorry, returns 5. Here also it returns 5. Pretty much the same way. Func, if also defined this way, if I define the remainder here, also returns would have returned 5 for the remainder, but here it will return 10. So that's what I'm saying. If you think about it, normally you cannot write objects and then give brackets. That happens only for constructors. Okay. Here in this case, I'm using the small brackets and putting 5, and it's giving me some output. So my function func, so my object, which is an object here, acts like a function. That's what it is, a function. And of course, func is an object, yes, but it's actually a class. Like it's actually defined to be a class functor. Now, that same named func, taking an input with and using small brackets, actually looks like a function. You could see the first line. Something with taking brackets is actually a regular syntax in C++ for functions. But I use the same syntax here for a struct, because the rem is an struct of name remainder. And because I have defined the operator small brackets, okay, to take n and return remainders. So this object now acts as a function. This is defined now because this code exists. Very similar to that, for function, func has a code which is this. So func behaves like a function, but it's actually a class. This is what exactly a functor is. A functor is a class, okay, which behaves like a function. All right. You can define it using square brackets, which I did here, but that is usually reserved for dereferencing operators. We have vectors and standard vectors. You usually use fifth element or something. Here, the syntax is thrown out of the window, of course, because I defined it this way. But nonetheless, you can also do it this way. All right. So the essential commonality between all these three, of course, I did not use remainder functor here because I didn't want to keep constructor, but you can also basically do the same thing here, like this, where replace the struct with class and just delete this struct. Everything will flow for remainder class. Okay, you have the constructor. It sets the private member, takes the operator, okay, and then uh, works like a functor. Okay, so the commonality is that something which is used as a function syntax is used for objects of struct as a function, objects of functor, which are of classes, also as functions. So that is the main idea behind showing all this. Okay. A syntax looking like functions is used by is used by something which is not even a function, but you can actually achieve the same thing. Okay. So the another reason to show it is Don't always think that this is a function. Okay, it could be a struct over with this kind of definition. Okay, same with it could be a functor. It need not be a actually a function. It could be an object of a class. Okay, the actual object it and the furthermore it actually has an more functions inside it because it's a class. You can pass around the object and have access to all its let's say these are public functions, so all its public functions. Okay, now let's look at lambda expressions. All right. So lambda expressions have a definite syntax. So I just put that first here so that you can relate. It's uh, different than what what you'll be used to. So just it's more like the syntax just takes a while to getting used to, but once you seen enough of it, you'll get used to it. Okay. So there's something called a capital list. Okay, inside square brackets, and then inside this small brackets, parameter list. Okay, and then the return types. Okay, and then the body. This is the syntax of lambda expressions. Okay, now we'll see an example and try to relate what it is. Put the return. Let's use auto. Okay, to define a lambda expression. It doesn't. I'll put the square bracket empty. I'll put the parameter list also empty, and then start the body. Okay, body has to end with semicolon. Okay, because still this is a single statement, so you have to end the whole thing from auto to here. Okay, with a semicolon. Now we'll see a body. Okay, as usual, print hello world. Okay, okay, that's fine. Then end the line. Okay, so what I essentially did is, again, auto is very useful here. I don't need to worry about whatever the data type here is. It's a string of sorry, it's a IOStream object, right? So it's in under IOStream. So standard cout has data type standard OFStream. I really don't need to care. I have the body. There is a return type to it. I just put auto. Print takes care of it. I mean, as in auto takes care of whatever the data type is. It infers from the body of the function. Okay, this is the return. So the return type is defined. We'll worry about capture list and parameter list, but for now, just think that this print function is a lambda expression. Okay, these are necessary for syntax, but left empty. And for now, we'll just focus on whatever is there in this small in the curly braces. Yeah, that is not part of the syntax. It's just to show. It's actually not part of the syntax. I'll just remove it or whatever. The arrow is not a part of the syntax. Okay. So now inside the curly braces, there is a code, a line of code. That is what is sort of like stored or called or whatever you can think of for print. Now, this is a function which is defined, a lambda expression. Print is defined. Okay. To use this, you do this way. Very similar to a function with brackets. And because it doesn't take any capture, so for now, you can leave it empty. There is no parameter list to take. Okay. Because that is left empty. Now you can just define print once. So let's see the output. So hello world gets printed. So to call this function, whatever variable you have defined, okay, you have to use the small braces to call that function, to call that lambda expression. The neat part is you can call it as many times. Again, like very similar to a normal function. The difference being lambda expressions are throwaway functions, as in they are not actually defined in some header file or you define it before main function or anything. They're just defined in a scope and used it. And then once that goes out of scope, okay, like of course there's a main here, but you can think like it could be in some other function also. So then print just gets destroyed. But function, if this print would have been outside, it would still existed. Okay. Because it doesn't get destroyed. So in that sense, lambda expressions are throwaway functions. Okay. So this is one way we define lambda expressions and then called it. You can also define it this way. Okay. And then be very careful. Till this is what I stored it here. I can add additional bracket, okay, and end the line. So I'll comment this for now to show that nothing gets printed. Okay. So here in this line, we just define the lambda expression print, store it. That's it. When you actually call the first print function with the brackets, like a expression, like any function, then it prints the first one. Okay. So I guess we're convinced that if I comment this, then it won't print anything. Okay. If I uncomment this, then yes, it will print. All right. But in this part, what I'm doing is I have the same syntax for lambda expression. First the square bracket, then the small brackets, then the curly braces. Okay. Only difference is that, and I add this part also, the small braces. Okay. Now let's see. Prints the hello world. So essentially, the lambda expression is from here to here. So if you add the small braces like we did here, okay, then it calls the lambda expression. All right. Okay. I hope the syntax is a little more clear now. So it will print 1, 2, 3, 4, 5, okay, plus 6. So you'll see 6 times it's printed. All right. Let's take another example. So important is there is a syntax to lambda expression which looks something like this. You have to have square brackets, you have to have small brackets, then you use curly braces. So that all these three together defines the lambda expression. To call it, then you add the small brackets, then it behaves like any other normal function, like this. Or you need not even define it to some name, you can just use it in itself. So this whole thing is self-contained. If you think I can actually comment the whole thing, just have this and it should still work. Okay. So the main function currently just has this weird looking lambda expression. That is also valid. Okay. If you make it global, then it does get defined, but that's it. To call it inside main, you have to actually put it in some variable. If you want to call it many times, or you can have it defined and executed outside. I don't know if that is allowed, but you can try. Yeah, let's see. Yeah, it throw an error. You can't define lambda expressions outside. All right. But let's say we have this. Then it becomes a global, but we can't store it. I mean, as in, I don't know. Let's see. Maybe this will work. Yeah. So storing inside a variable outside main becomes a global variable. Okay. That we can access now and then do all this. So that should be fine. All right. That works. All right. This should also work. And that's all right. Okay. Any questions? Okay. Okay. Moving on. Another example. I have stream, username, return 0. Just out of habit. Okay. All right. So now the actual what do you call it? Code. I have if-else statements. So if-else will have its own braces. Okay. You can put spaces, that is fine. Just for clarity, I'm putting spaces here. Okay. You need not put it, but anyway, nonetheless, the code will still work. Okay. Now I'll have the lambda expression. There is, remember the lambda expression? First the square brackets, okay, capture list, then the parameter list, and then the body. So I don't want to worry about capturing anything, but now we'll move on to the next part where we'll see the next step where you have a parameter list. The parameter list is basically defining, it takes two variables, A and B, which are integers. Okay. Now the body. Body says return A equal to B. And I have to end that body. Okay. And then this lambda expression expects inputs. So if you see here, to call this function lambda expression, I had to put brackets. Because I did not give any parameters to it, I do not put anything here. I did not put anything here also. But because I'm saying that lambda expression expects two inputs, A and B, so I have to call. Sorry, there a question. All right. Sorry. Oh, sorry. Anyway, moving on. So here the bracket expects two inputs. Okay, so we can maybe give 8, 8. So it will check A and B, check if A equal to B. That is what it returns. So for this if statement within these brackets, this is the lambda expression complete thing with some return type. Okay, here it needs to be Boolean because if else statements expect only Boolean returns. All right. So that's there. And now the body of the if statement. If this is true, so then we print true statement. as in the true part of the statement was executed. You can name it whatever, but for now I'll just name it this. Then else the pretty much the opposite of it. So first statement, false part was executed. All right. Now let's compile and print, compile and run. So the true statement was executed because the input parameter here were 8 and 8. Yeah. I'll just give another example here. So let's say I give 8 and 9 just to show that it goes to the next statement. So it prints the false statement, as in it prints the else part of the if. Okay. To repeat, I'll go to the previous example 8, 8 and just show prints the true statement. Okay. So we are able to consistently reproduce what we want, what we were expecting. But going through the code again. So the if part, okay, starts with a bracket, and inside it, from here till here, is the if clause, as in it should be true or false, because that's what if expects, right? So now let's break this down. What is it? So it's a lambda expression. So the syntax for lambda expression is first the capture list with square brackets, okay, so something like this. Then the small brackets, which is a parameter list, okay, is there, and then the body with parentheses. All right. Here, sorry, previous. So in the previous case, I did not have any input parameter. So when I call the lambda expression function with the brackets, I did not put anything else. Yeah, I'm coming to that. So we'll make it go step by step. Just to understand this first, let's look at this example. So yes, we can do that. So yeah, here in this case, I did not take any input, but so no, sorry. Hence, if I call the lambda expression function, okay, to execute, if I put those brackets, I did not put anything inside it because it doesn't expect anything anyway. Hence, sorry, hence I can just call them simple this way. Here in this case, since I did not define this lambda expression, okay, I don't put it inside some name. I just on the fly defined a function with no name, okay, call that function itself. So here it doesn't expect any input, hence it doesn't also take any input. And this then just prints the body. Yes, I agree. One can say this is unnecessary. You can just have this line itself, which it will execute. Absolutely true. But to show this example, we are writing the lambda expression on the fly and just executing it. Okay. Technically speaking, this is inside some scope also because there are curly braces. So scope rules still apply. Now coming to this example, here I have a lambda expression. So we saw that whatever is inside these small brackets for the if statement needs to be true or false, right? So let's focus on this thing only. Ignore everything else. Okay. So whatever I've highlighted, just let's focus on that. Now this is a lambda expression. The first part is the capture list. Okay. Has square brackets. We'll not worry about capture list for now. We're only worrying about the next part, which is the parameter list. This guy, which was empty before, but this time we're putting it as some parameters. Now it is basically like a function. Okay. So if you see this function, has a data type, has a function name, and has a list of things it takes as a parameter. Essentially that it takes two parameters. This lambda expression takes two parameters. Importantly, if it takes two parameters, it needs to know its data type. We cannot ignore that. So integer a and b. All right. The body of the now it comes to the body of the function. This is the syntax, right? Now next is the body. Now that body has written A as A equal to B. So it compares two integers. If they're same, it returns true. Okay. That is what is returned for the whole lambda expression also. Okay. So it returns true if A is B or not, and else it's false. So till here, from here to here, this is the lambda expression. But now we have to call the lambda expression. So hence, we put the brackets, all right, and pass the parameters. Yes, granted, I actually explicitly pass the parameters, but nonetheless, just to understand this example, let's pass 8 and 8. So the function is actually from here to here. And I'm calling, so this is very similar to remainder, just that I have not given it a name. Okay, I can actually give it a name and also do all this, which will do that. But just to keep it back of your mind, from here to here, this is the function. And then you're putting brackets and giving two parameters. So for the context of this lambda expression, A is 8, B is 8, and then it compares A equal to B, which is 8 is 8. Yes, so that is true. So the whole thing, okay, returns true. And hence the true statement was printed. And when I give any other output, so like let's say 8, 9, then it prints false. Okay. I hope this is clear. So question? Hmm. So the first one, there is a slight, okay. So the last two braces won't be there. The curly braces won't be there, but otherwise, yes, that is a lambda. If A is less than B, then A uh, question mark B. See, if you're using question mark, the ternary operator, then you have to use it properly. Uh, Ternary operator has a colon also. So it returns if A is less than B or something. So that is the question mark before the question mark. So if I rewrite your thing, uh, A less than B. So instead of A equal to B, you can have A less than B. So let's do that. Takes A and B and returns. But the problem is it's not a if else statement as in if I'm returning A less than B or so on. Okay, so actually putting them in if else statements doesn't make any sense. What we'll do is write the lambda expression, integer A, integer B. Okay. Now the body returns the ternary operator B. Sorry. First the conditional. So if A is less than B, okay, then returns A as B. Very important thing to note here in this lambda expression, okay, the return type was equal to, as in a Boolean. So it infers that the whole thing, when executed, will return a Boolean, which is what a if statement expects. But here, I have written a lambda expression, but it returns an integer. Either way, if A is less than B or A is greater than B. Okay. So now I have to give it inputs. So like let's say 8 comma, which you had was 8 comma 6. Okay. All right, then end the step and the uh, expression. What do you guys think will happen now? You can print and see. Let's comment this also. So we only see the output for this. Any guesses? What we'll see? It will return false, yes, but not print anything. Oh, my bad. It has to have a return statement. Sorry. Is there any question or okay? Oh, sorry. Yeah. Yeah. So like I was saying, yes, it will return false, but not print anything. Can you think of why? So from here to here, this is a function, yes. a lambda expression takes inputs 8 and 6, but we did not store it into anything or even a print statement. So it won't do anything. It's not printing, it will return only. Yes. So to actually see the output, we have to put some kind of statement. Okay. So all right, this should be here. I'll put mm, greater. Oh, sorry. Here it returns less, right? Lesser of whatever this output is. So I'll just copy this one. Okay. Oh, sorry. My bad. Yeah. Oh. So right. So put in the proper syntax. So the lesser of 86 is 6. And to check that, we did not define a function. We just wrote it on the fly. Okay. Now the nice thing is this function, okay, since it takes variables like this here, you can define it outside and call it inside here. Okay, you can also do that. So we'll look at some examples. Like let's go next level higher than this. Now I'll use auto. Okay. Is there a question? Yeah. So yes, that's the thing. Writing one-line functions is something a lot of people really like. So that's something you can actually do in lambda expressions, and actually don't have to define a function also. Doesn't name it even. You can just on the fly declares like define and declare everything like a lambda expression like this, call it, and then it's done. So if you think about it, this lambda expression has only scope till this one line. Okay. I mean, it takes actually 3 lines because of formatting, but essentially for C++, this is just one line. And this lambda expression is only existing inside this one line. Okay. All right. Let me define something called a clause. Okay. Which is essentially the same thing that we have here. Basically, to make it a little more neater and looking, I understand I made it horrible looking at first. There was a sort of intentional. Now let's clean this up a little bit. I hope you still get the idea and it's clear. I'll define an auto clause. I'll format it now. Okay. So the clause is essentially this guy. Okay. Takes input and everything. All right. Now use clause as like a function. If clause takes inputs, I'll give why not 9,9. And then it prints two statement. Else, oh, sorry. Yeah. So else prints false statement. Same thing. You can check for 8,9 also. All right. Lambda expression 5. So the first statement is true. Yes, 8 is 8. Second one is lesser of 8,6 is what we wrote. So 6, that's because it has to return the lesser part. The next is defining a lambda expression clause, okay, which has this whole lambda expression inside it, and then call it like a function. So it takes two inputs, it expects two inputs here. So we're giving it, and then if just putting inside if and else statements, we can get corresponding outputs. So for 9,9, it will check If it's same, then yes, it will return the true statement as it does. 8,9. It is not the same, so it returns the false statement. Okay. Any questions so far? Awesome. Okay, so finally, now let's do the same thing that we started with, but through lambda expressions. I'll define integer main. Okay. I'll define m equal to 10. But now this not as a global variable, but inside the function itself. Okay. Now I will put lambda expression auto. Okay. We saw the syntax, right? So first of all, we saw only the body, okay, with no input and with no parameter list and capture list. Then we saw with the input list here, but again, no capture list. I guess where you can guess where this is going. This time we will have a capture list, and this time it will be M itself. Okay. And I guess you can sort of guess what will be the parameter list. It is the capital N itself. Okay. So inside capture list, I'm defining M. Okay. I'm defining M outside and passing it here. And then this is the parameter list, parameter part inside the lambda expression. Okay. Now we'll write the body. This will be return M percentage M. Now to end the body also. Okay. Now to have this syntax. And the whole thing needs to be ended because this is a single line. Okay. Can format it. Look something like this. All right. Now let's print it like we did before. So remainder. Awesome thing is I can call this like a function. Okay. And I will just put it here now. Yeah. Then that's it. Return 0. Let's see the output so that we're convinced that this is a valid syntax. And then I'll repeat, I'll explain it. The remainder is 5. Okay. So, right. Pretty much similar to this one. So if you see the body of like the main from line 9 to 14, it looks exactly the same. Like this part of the body, I just call not line 9, I mean, you get the idea, line 11. So standard C out, there is a remainder. I call something which looks like a function, and here it is indeed a function. Here it indeed is a function. Pass 15 to it, standard Indian, and done. Very much similar to that. I have a function, takes 15, ends. So lambda expressions, again, to reinforce the idea, they are also functions. They're called like functions. Okay. But they have their own set of syntax, and we have to respect that. Now, integer integer M, 10 is defined. Okay. And we define the remainder with an auto because I don't want to worry about the return of the return data type. All right. So now the important thing is lambda expressions normally don't have to return anything. They can just be some expression, some print statement or anything. Okay. Here, because I want to print stuff and pass it to the stream. Okay. Yes, I'm returning it. Now, the remainder function, the lambda expression, has a first is a capture list. So it captures 10. Okay. Now, important thing here is similar to how we had a constant, as in for that function, M we do not want to change. In struct, it becomes a private member. So we don't want to change for that object. And in, I mean, similar, even in a class also, you can do the same. We don't want to change. Okay. In a lambda expression, once it captures M, that's it. That's the value it takes. You cannot change the captured value. Okay. And but you can reuse the lambda expression with different inputs to the parameter list. Okay. So it behaves pretty much similar to that. You can call this function with different inputs like 15, 10, 20, or whatever. Do the same with the lambda expression also. Okay. Important thing, while calling this function, hence you don't need to pass the capture list, because while defining the lambda expression, it is already done. And this value is not going to change. We'll look at more examples, but this is how you use lambda expression for doing the same thing that we did three ways. Using classes, I mean, we didn't, but we can sort of also use classes, using structs, and using plain old functions. Okay. Mm, body part also we can use cout, yes. So instead of a return, and maybe I'll write this way. This will create and store it. So what I'll do is, and instead of the remainder, uh, the stream. Okay, so captures n, takes n, then prints standard cout, remainder, n percentage m. Okay, done. And then to call this function, I have to pass something. Okay, so that is 15. Okay, this should work. Let's comment this for now. M needs to be there because still has to be captured. Okay, so still prints 15. So for lambda expressions, you don't actually need to return. We wanted to, I wanted the syntax to look basically the same like in the first line. Okay, here. So I just put it, but you can do the exact same thing in this way also. Okay, all right. You can define some variable a equal to 15 and pass a here also. That's absolutely okay. Okay, all right. Any questions? Clear, right? All right. Next example. Okay. Oh, sure. Yeah. Actually, all this code that I discuss, they'll be in the Google Drive, which I've shared in the link last class or last before that. I'll update the folder also with the this week's code. So yeah, I mean, no worries. We can still write that. That's good. Okay, let's take another example. Okay, so define main function. Yeah, sure, absolutely. Yes. Lambda expressions just take a while to get used to it. They have a certain syntax. You just have to understand the syntax. That's all. Once you get used to it, it's not very difficult, I feel. And actually, in anything, if you get used to it through, like after, like if you get more exposure to it, you get used to it, everything becomes easier. Okay, every concept. however hard it is, it feels easier later. All right, this time, let's have the temp 0, okay? And I'll define a sum lambda expression as in the variable sum, okay? With auto, as usual, we don't have to worry about what the return type and everything is, or if there is a return type, okay? So here it had a return type, which was output stream and all that. So we didn't have to worry. Here it was integer. Again, auto takes care of everything. All right. So capture type. Instead of just the value, so remember when I said this capture M, actually this is a good example to take. Let's say, mm, this is good. No, I'll just tell M equals to 5. What do you think will be the output? So I have 10 here. I made the lambda expression. I set n to 5 again, and then call the lambda expression. Okay. It is still print 5. Ignore this guy, maybe for the sake of this example. Let's repeat that and ignore the second line. It is still print 5. The reason is it is very similar to the examples we saw before. The M, sorry. Yeah, so it will actually just capture it. Okay. Okay. So remember, in this example, we had M as constant 10. So essentially, it is like I want to keep the divisor same as constant. That's what I did here with the global variable as const. The second example, I kept it as const for a given object through its private member. So I can make it const also, okay? But think of it like once I initialize the object rem, if I call it through its operator, I cannot change it anyway. So because I don't have access to private member anyway. Okay, so that was the idea. So to keep the divisor same here. And similarly with class also you can do the same. So that's the thing. Sort of the same thing actually happens naturally with lambda expressions, where when it captures M, it actually captures the value. So nth value is 10. So it will capture M and then that's it. For the whole expression, it puts 10 here. Done. So when you call remainder with 15, it will use the value of M as 10, not as 5, because the capture is already done. Okay. This is an important concept in lambda expressions. The capture list is fixed in a way. When you actually declare or define the lambda expression. The parameter list is the one which actually keeps changing. So you can call the remainder function with 15, 20, and so on. So this is the part which is variable to that function. Yes, if you move it up, then yes, it will change. Because then the capture will be for 5, not for 10. You can print it and see the remainder is 0. Okay. All right. Awesome. I hope this is clear. So now what I'm going to do is do something similar, but now write a lambda expression. Okay. As usual, we'll have all this. This time the capture will be with a reference of temp. Remember, here it was with a the capture was with a value of M. Okay, but this time is with a reference. I think you can guess with all the lectures so far. You can guess where this is going. Passing my value and passing my reference. Okay, same idea. So we'll do in the body. All right. Technically, reference is not a pointer, but the idea is that they sort of mean that for this function, temp is the same. Okay. So now let's say I call sum with 15. So initially temp, so when it was declared, temp was captured, okay, with reference set to 0. So that is fine. So initially for this, for the sake of this function or lambda expression, temp is 0. When I call sum as 15, okay, so then and it takes this expression sum takes 15 and adds to it. That's what the return, as in not even return. The you can think there is no return. And should I end this? Yes. There is actually no return, but that's what it keeps track of. Okay. It takes and updates temp, which is the reference taken as reference. And temp is defined outside the scope. So we can actually print temp. Let's do that. Okay. Standard C out. So we'll call whatever is the state of sum and just print temp. Okay. It's only adding 15 to 10. Yes. That is the goal. Do it multiple times. This is just to show you the difference between captures. Okay. This is, yeah, that's fine. Okay. All right. Normally, like you see here, changing M did not change anything because the capture was already done by value. But this time we did the capture with a reference. And this body doesn't return anything actually. It has a statement which it keeps track of. So this sum actually, if you think about it, it doesn't have any return type. It should be void. But it has a body where it updates temp with N, which it takes many times. Okay. I hope you appreciate the code here, as in because normally temp, if it was passed by value, it would have updated it and done nothing. Okay. Okay. But because we pass it by reference and it is defined outside, I can actually keep track of the sum now. So it actually updates because it's a reference, it updates to the previous value. Hence we see an increment of 15. How many times we print? Okay. I hope that is clear. Next example. Oh yeah, we can check that. So let's say I just remove this. Actually, can you guess what will happen if I do this, all this and print? Basically, what will this code return? I just removed a simple ampersand here. Do you mean it will have the same output as this? That's incorrect. It won't. So actually, it will only print 15. Oh, my bad. What does happen? This is oh, sorry, my bad. So what happens is we cannot add or change it. So when you capture, uh, when you pass something in the capture list, you actually cannot change the value. That's not actually another thing. I thought it might change it. So I was expecting it to put 15 every time to 0, and because it was capturing 0, so the expectation was it will capture only 15, as in print only 15 every time. But so turns out that you cannot actually change the capture list normally. Okay, so that's what this one says. But if you put it as a reference, then you can. Okay, that is allowed. All right. Include stream. Okay. Make function. We'll define a val called 0. Another reference, another variable called, I call it ref. Okay. Now, after this lambda expression is checked, takes two capture list. Okay. Takes value as the value has to be defined. Okay. That immutable value, as in you cannot change this value anymore, and a reference, sorry, as a ref. So these are the two variables for the capture list. And then the parameter list. So I'll just call it param1, parameter 2, also integer. Now the body. Print value of val. Then print ref. Then parameter 1. Then print parameter 2. Then that's the variable. Then inline. So what we're trying to do is essentially have some kind of capture list, takes parameters, and then we just try to print everything. Okay. Now let's see actually what happens. So what I've told you guys so far. Okay. So these are the questions. What will be the output for all this? Okay. Check. I'll keep the parameters then. This time I'll change the parameter. And then as usual, we can see it. All right. Give this a try and let me know the answer. So essentially the lambda expression gets called 3 times. Okay. Each time with the, I mean, there are some parameter it takes. Yes. But it also happens that I change some variables also. I mean, these are not constant. So because they are defined to be constant, I can change them. So 3 different cases. And I'm pretty sure we can all agree it will print this line. So, and 3 times. So what will be the each of the output? Right, we did not. Is that okay or not okay? So what do you think will be the outputs? As in, do you think it will throw an error, not compile, do weird behavior? Mhm. Okay, let's see. Did I miss some part? Oh yeah, my bad. As usual, I miss the lambda expression thing. Okay. No, actually. So what happens is for capture list, the thing that you pass by value, okay, not as a reference. So ref is so to keep track of things. The ref variable is passed as reference and val is passed as value. So val value, which gets captured and stays constant, needs to be defined. The ref actually doesn't need to be defined. Okay, because before calling the lambda expression, I actually define the ref. Okay, so when this lambda expression gets called, the parameters get initialized. Yes, so that will print the correct parameters. Parameters are 10 and 11 for the first line. Yes, but it has a reference as captured. But now because reference has been defined to be 4 and passed as a reference, the ref, it prints ref as 4. If I hadn't done that, then yes, you're right. That probably printed some garbage or 0 or something. Or it printed 2 because why not? Yeah. Okay. The second line, I set val to be 5. Doesn't matter because val is already captured to be 0. Okay. So that's what the val prints. Line 2 output, it should be 5. Which line? Yeah, no. So this is, I haven't printed it. So it's 4. Because ref is defined to be 4 before calling the lambda expression. If I set val to be 5, it doesn't matter because val has been captured to be 0 already. Changing val won't change the lambda expression. Val. So val still remains 0. In ref also changing it, it still remains 0. Because I defined ref to be 4, in these two cases, it prints to be 4. I change ref to 17, then it changes to 17. Yeah. Uh, just so you know, while capturing, what matters is the value gets captured and stays constant. The reference value, even if it's not defined, it just needs to be defined before call, not during the actual uh, declaration of check. So if I had done this, then it takes the value, whatever it captures. So it is some garbage here. So that's what it captures. Okay. And stays constant for the whole thing. Even if I change val to 5, it doesn't matter. It has already captured val to be whatever it was here, which is this guy. Okay. So if I set it to 0, then still remains the same. But because ref is taken as a reference, it can still work if I comment this, which are where it actually printed 2. Ref was printed 2. I don't know if what it will print now. Yeah, okay. Let's say it printed 2 again. That's fine because it captures whatever ref it gets. If I set it to 4, because ref was taken as a reference, it when function gets called, it takes the reference value as in whatever ref has. So now it is 4, so it will print 4. So let's do that. It prints 4. The third one, when I change ref to 17, it prints 17. Here I change val. So ref hasn't changed. So it stays the same as 4. And this I think is clear. These are parameters 10, 11, 10, 11, 1, 2. So 10, 11, 10, 11, 1, 2. they don't get affected unless you're using printing something which uses val, ref, parameters and all. Okay, then this will change, but I hope the idea is clear. Yeah. So the important thing with lambda expressions is you can have a capture list, you have a parameter list and a body. The parameter is fine. You can just, you're passing some values. It's as like a normal function. And body is something which works with all the variables here, the capture list and the parameter list. The extra thing to take care of is, and very important, how is the capture list done? If it's by a value, then it is constant. It doesn't change for that lambda expression. We might change it later on as in outside the body. That's fine. But it doesn't affect the lambda expression. Because it was captured in value. But if it captures by a reference, then if you change the value, then it automatically captures that new value also. Okay. All right. I hope so far so clear. We'll take another example. A stream again to print at the main function. So similar to previous one, okay. This time I will define val. Okay, let's say it is 0. I'll define ref. Okay, just defined. I don't want to set it yet. Inside the main function, I'll define a struct. Check, let's say check function or check underscore. Okay. Now this itself has a val f, okay, an integer with a reference ref f, a check underscore f constructor, text val, text integer reference f, then sets val f as val, also sets ref f as ref f with ref, then body I don't need to worry about it. Then the void operator okay. So I define this operator. Its inputs as param1, param2, and then basically I'll copy paste the whole. So there it was a lambda expression doing all this. This time there is an operator which how do you put it? Does the same job, okay? But using this operator now. All right. I'll have an auto check. So check underscore f is basically the temporary struct that I have created. Auto check is essentially this guy, which I have done. All right. And then set check f with the val and ref. Okay. Basically, these guys. I'll format it to make more clear. Basically, these guys are passed into check underscore f, which itself is an object of struct. Okay. And then I return that to auto. Okay. Now I will copy this whole thing. Okay. Uh, val and ref are constant, right? They're not. So val is integer, so no const qualifier. Ref is also doesn't have any const qualifier, so they both can change. So if you see the whole thing here, this was written using lambda expression. Here I just put something like a struct in between. Okay, same code, but struct using struct. What do you think will be the output if I print this guy now? Yeah, honestly speaking, it will be exactly the same output because if you think about it, uh, uh, till line 6 here, it is same. But from here till here, there's a struct with some code. But here there's a lambda expression. And from here till here, like from line to 12 to rest, it is basically this code. So yeah, it will be the same. Did I make a mistake? I probably did. Uh, yes, my bad. So here it needs to be val f. Yes, here it needs to be ref f. Paramounts are okay. That should be good to go. All right. Now we are good to go. So what I'm trying to get at is whatever this code does, essentially you can replace with a lambda expression. We went about it a different way. So I wanted to explain what lambda expression does with capture values, references, and everything to repeat the same functionality, which doesn't exist in C. So C++ has lambda expressions. To use the same functionality in C, you have to write a struct and define variables this way, define the operator, and then you can write pretty much the same expressions, so like a function, what we do for lambda expressions. I hope you can appreciate writing a throwaway expression like this and not writing full-blown structs to do the same effect. Okay. All right. They kind of are, but from perspective of how much code I have to write just for a single expression, I think lambda expression is also quite small. So yeah. Anyway, for this is a very simple example, and honestly, for this specific example, yes, we can write in both ways. Just what I wanted to show you. You can use lambda expression to write some same code. Can you also use struct to write the same code? Basically, going back to the first one, we use functions, we use structs, we use classes to write some kind of code. Then we use lambda expressions to write the same thing. Okay, lambda expression to write the same thing. Now, since I used lambda expression to write something, I'm using struct back to write the same thing. Okay, coming back in a circle, basically. All right. Uh, any questions? Awesome. I guess with that, we can end today's class. This was supposed to be, so for 12-week course, this is supposed to be a last class, but I'm taking another extra class tomorrow. So that will be the actual last class. And yeah, so far we have covered a lot of topics, and templates was a very important topic that, sorry, lambda expressions was something I really, this is all lambda. Yeah, this is lambda expressions. So this is something so tomorrow, same time, 6 to 8. Yeah. So next class is tomorrow, Wednesday, 6 to 8. That will be the last class. So like, yeah, I was saying, whatever topics that we've covered, out of this templates, again, sorry, I'm mentioning templates again. Lambda expression was very important. So we covered that today. Tomorrow I'll cover smart pointers. Okay. And that should end the more or less at least most of the topics, important topics in um, modern C++, right? I hope with at least these topics, you should be able to more or less handle any concept in C++. There are definitely a lot of other concepts, but at least I feel this lays a very good foundation for all the rest of the topics. The same link, whatever link you are joining using, have been using to join, that is the same one. Yeah, I keep the same link so that if I keep changing it, becomes little troublesome for people to keep track. So I just keep the same link. Leave the same link, uh, same time tomorrow. Yeah, it's not. It's actually once you uh, try to, I mean, it's essentially getting used to things. Once you go step by step, break down things, go learn the syntax step by step. It's not hard. I mean, once you get used to it, nothing is really hard. It does look little scary or hard at first, but honestly, it's not really. Yeah. Awesome. I hope you enjoyed today's class also. So yeah, keep practicing. Uh, yeah. Yes, same. Even I was also getting confused with lambda expressions, but once I uh, got to, yeah, yeah, it's been fun. It's been fun. It's been, yeah, even once when I got to learn step by step each of the portion, things click. Yeah. Mhm. All right. So with that, I guess we can end today's class and I'll see you tomorrow. Again, keep practicing this kind of concepts. So the more you practice, the more you learn. Again, as like I said, you just have to get used to these concepts and syntax, then everything just flows. Okay, awesome. Yeah, happy coding.